For these notes, we're going to be talking about composite figures. All right, so composite figures are figures that can basically be separated or broken down into parts that are basic plane figures. So for example, in the figure shown, we could break this down into two basic shapes, a rectangle at the top and then a trapezoid underneath. Okay, so together it makes this kind of strange looking figure, but we can break it down into two much more basic and easier to find the area of shapes. So if you want to find the area of a composite figure, so to find the area, you find the area of each shape, each smaller shape, or each region. And then if I know the area of this rectangle, I know the area of this trapezoid, I add them together, I take the sum. So find the area of each region and then find the sum of these areas. All right, so let's get a little bit of information about this figure. So let's say that they tell us that this length is 23 centimeters. This is a right angle. All of these are right angles because it's a rectangle. This is 12 centimeters. This entire distance is 18 centimeters. And we'll say that this is, let's see. Say that this is also 18 centimeters. All right, so using that information, we're going to be able to find the area of the entire shape. Okay. All right, so we've got two shapes. I like to use highlighters when I have composite figure problems because I like to be able to see the different shapes that are there. All right, so my first shape is a rectangle up here. So first we need to find the area of each region. So find the area of each region. So I have region 1, which is a rectangle, and region 2, which is a trapezoid. Okay, so let's find the area of region 1 first. So it's a rectangle. Hopefully we have the area formula for a rectangle memorized, but if you don't, you got your formula sheet, find your rectangle, A equals, it's always the A equals formula. So the area of a rectangle is length times width. Awesome. So area is length times width. So looking at our figure and the numbers that they've given us, what is the length and the width of this rectangle? Well, it looks like the length and width are going to be 12 and 23. So we've got 12 times 23. We'll multiply those. And we should get that the area is 276. And since we're talking about area as a measurement, we need to include the units. So 276 centimeters squared, or you might see it written as square centimeters. Okay, you should be able to recognize that both of those are correct. All right, so that's the area of figure 1. So that's really important. I'm going to circle that or highlight it or something, and I know that that's for figure 1. Okay, now we need to find the area of figure 2. Figure 2. So what shape is figure 2? It's a trapezoid. So we're going to go to our formula sheet, find the trapezoid. Here it is. And there's our area formula. Again, these are what's going to be on your test, so you don't have to memorize these. You just have to know where to find them. So the area formula for trapezoid is 1/2 times the height of the trapezoid, and then B1 plus B2. All right, in case we've forgotten, what in the world do B1 and B2 mean? Well, look at the picture on your formula sheet. Find B1, find B2. These are the two parallel sides. All right, they're not always going to be horizontal like this. They might instead look vertical lines like that, but it's the two horizontal, the two parallel sides. All right, and then the height is the perpendicular distance in between them. Okay, so for this we have area is 1/2 times height. All right, I'm going to come back to that in a second. Times the sum of B1 plus B2. So the top base is just 23, and the bottom base in this case is 18. Okay, so I didn't write the height because it doesn't automatically give it to me. We have to actually figure that out. Well, if we know that this entire figure is a total of 18 centimeters, we're only looking for this vertical distance, okay? So what could help us find that? Well, if the entire thing is 18 centimeters, we know that the rectangle is 12 centimeters, so 12 of those 18 would mean that there's a remaining 6 centimeters. Now in my picture, it's not drawn to scale, so my picture doesn't look like 6, it doesn't look like this would actually be less than that, but remember, don't always trust the scale of the picture. Okay. All right, so now we've got our formula. We can go ahead and simplify that. So we've got 23 plus 18 is 41. So we find that the area of section 2, the trapezoid, is 123 centimeters squared, or square centimeters. Okay. And I'll use my different color to highlight this. That's the area of that part. Okay, we had two different regions. We had region 1 and region 2. We found the area of both of them. So to find the area of the entire figure, we're going to find the sum of these areas. So we're just going to add up what we got for 1 with what we got for 2. So 276 plus 123. Let's see what we get. We should get 399 centimeters squared, or square centimeters. And that's our final answer. The area of the total figure, the total area of the figure is 399 centimeters squared. All right, so that's one type of composite shape where you have two figures put together. I want to show you one more type of composite figure. All right, and this time it has to deal with a shaded region. So let me show you what this looks like. Okay, so we're going to start first. Let's say we have a circle. Okay, and then we're going to draw a box around that circle. And I don't have a stencil that's going to match that, so I'm just going to try my best. Okay. All right, and I'm going to tell you that this is a square, and then this is a circle. Okay, we're not going to deal with ovals or anything like that. It's just going to be circles or semicircles. So in this picture, I'm going to shade in this region. So it's the region that's kind of around the circle. So shaded regions is this type of question, so finding the area of a shaded region. So here's how we're going to find it. We're going to find the area of the total figure. So find area of the entire figure. So by that, I mean the area of this largest part, the area of this square. Then, once we find that area, we subtract the area of the non-shaded region. Okay, so a lot of times whenever we're dealing with shaded regions, unlike the first method where we were adding parts together, this time we're actually going to be taking away the non-shaded region. So find the area of the entire figure, then subtract the area of the non-shaded region. Okay? All right, so we have the entire figure as a square, and let's say that this square has a length of 25 feet. Okay, and we're going to pretend that this circle actually really does come to the edges. So this has a radius. Well, what would this radius be? If this length is 25, that means the diameter is 25. So that would make our radius half of that. So our radius is 12.5. Okay. and we'll say feet. All right, so let's find the area of the square. Okay, so area of the square I'm going to say is the first one. Okay. Well, how do I find the area of a square? Look at your formula sheet. It should say that it's side squared. So this square has a side length of 25, so we're going to do 25 squared. And we get that it has an area of 625 feet squared. All right, so that's the square. And sometimes you might even want to write square so that you're keeping track of what shape you're finding the area of. All right, now we're going to find the area of this non-shaded region. The non-shaded region is a circle, so we'll call this region 2. Right? We need to have the area formula for a circle. Area formula for a circle is pi r squared. And we said r is 12.5. So area is, let's use 3.14 times 12.5 squared. Let's see what we get. And we get that the area of this is approximately 490.63 feet squared. So remember, this is the area of the non-shaded circle. Non-shaded part. Okay? So we're only looking for the area of the shaded region, so we're going to take the area of the entire figure, 625, and subtract, remember subtract, the area of the non-shaded region, 490.63. So let's see what we get. So we should get 134.37, and it's still area, so it's going to be feet squared or square feet. So this represents the area of the shaded region. Okay? Awesome. All right, so moral of the story, takeaway from these notes, if you're looking for a shaded region, we're going to subtract. If you're looking for a more traditional composite figure where it's just multiple figures kind of linked together, matched up together, then we're going to add. All right, good luck.